This video is on transformations of polynomial functions. So looking at example 1, it says for f of x equals x cubed minus 6, write the rule for each function. So let's look at 1a. Okay, so 1a says g of x equals f of x plus 2. So the rule is just a new equation. So the rule is a new equation. And then we're going to say what happens. So look in the rule, new equation. So I want to take f of x and I want to add 2 to it. So what that looks like is, of course, it's g of x. I take my original f of x function, which is x cubed minus 6, and I add 2 to it. Then I just combine like terms. So I get g of x equals x cubed, and then negative 6 plus 2, then negative 4. This is my rule. Now, what happens with it is minus 4, it's on the outside, it's not connected to the x, so it just goes down 4. And that's all for this example. So all of that's my answer. Now, looking at B, notice that the f of x is no longer just f of x, it's f of x plus 3. So now, anywhere I see an x, I'm going to substitute in x plus 3. So my function is h of x, and then instead of x cubed, it's going to be x plus 3 cubed minus 6. Okay, then there's nothing else I can do to simplify, so I'm just going to state the transformations. So plus 3, remember we've got to think of opposite, so we would think it goes in the positive direction to the right, but it really goes left 3, and then that negative tells me it goes down 6. And that's everything I need to know. I have my rule, which is the new equation, and then what transformations take place. Looking at example 2, it says for f of x equals x cubed plus 4, write the new rule, and or write the rule for each equation. So A, we have g of x equals f of x minus 5. So again, I have g of x equals my original f of x equation, which is x cubed plus 4 in this example, and then I subtract 5. Well, again, when I combine these like terms, g of x equals x cubed 4 minus 5 is a negative 1, and then the transformations that take place is it goes down 1. So there's that. Looking at B, we have h of x equals f of x minus 2. So I take h of x, anywhere I see an x, I plug in x minus 2, so I get x minus 2 cubed plus 4. Then the transformations, it looks like it's minus 2, but on this one we go to the right, which is in the positive direction 2, and up 4. So this is the transformations for that. Looking at the next example, we're going to talk about reflecting across the x and the y-axis. So example 3, let f of x equal x cubed plus 5x squared minus 8x plus 1. Write the function g of x that performs each transformation. So in example A, we want to reflect about the x-axis. So this part right here, g of x equals negative f of x, is kind of like our hint to us. So what I need to know is I have g of x equals negative, and then everything f of x is. So x cubed plus 5x squared minus 8x plus 1. So now what I need to do is I have a negative in front. I can look at it as a negative 1, and I have to distribute. So negative 1 times x cubed is a negative x cubed. Negative 1 times a 5x squared is a negative 5x squared. A negative 1 times a negative 8 is a positive 8x. Negative 1 times a positive 1 is a negative 1. So this is my new function that shows that it's been reflected about the x-axis. So what I ended up doing is I changed all the signs. Change all signs. And that's how we can show a reflection about the x-axis. Looking at the next part, reflection about the y-axis, this is where it gets a little more tricky. Notice now the negative x is on the inside. Okay, so that means everywhere I see an x, I'm plugging in a negative x. So what that looks like is I have a negative x cubed plus 5 times a negative x squared minus 8 times a negative x plus 1. And the 1 does not get a negative x because it does not have a variable with it to substitute in a negative x. Well, I can also look at it as these are negative 1 x's. So I need to cube it. So remember, I have negative 1 cubed x cubed. Here I have 5 times a negative 1 squared x squared. Here it's raised to the first power, so I can just end up multiplying, but it's negative 8 times a negative 1 times an x, and then plus 1. Well, negative 1 cubed is a negative 1 times x cubed. Negative 1 times x cubed is just a negative x cubed. Here I get 5 times negative 1 squared is just a positive 1 times x squared. So 5 times 1 times a negative x squared is just a positive 5x squared. Negative 8 times a negative 1 is a positive 8x. So I get a plus 8x, and then the plus 1 just comes on down. So I get g of x equals that. And if I notice, the only signs that changed were the signs of my variables with odd exponents. So my x cubed, the sign changed to negative, and my 8x, the sign changed to positive. Okay, so when we're reflecting about the y-axis, we only change the signs of odd exponents. Okay, odd exponents. So we're going to try these again with a new equation, and we're just going to use the shortcut that we used. So example 4, we let f of x equal x cubed minus 2x squared minus x plus 2. Again, we want to write a function that g of x that performs each transformation. So looking at A, it's reflecting across the x-axis. So remember, when it reflects across the x-axis, we just change all of the signs. So I get a negative x cubed plus a 2x squared plus an x minus 2. So there's the function that reflects across the x-axis. For B, we want to reflect across the y-axis. Remember, the y-axis, we change the sign of the variables with the odd exponents. So I look at x cubed, that's an odd one, so that becomes negative x cubed. Negative 2x squared, that's an even exponent, so I keep it as a negative 2x squared. Negative x, that is an odd exponent, so I change it to plus x, and then the plus 2 because it doesn't have a variable with an exponent. And there's the new function that reflects across the y-axis. Looking at example 5, it says let f of x equal 2x to the fourth minus 6x squared plus 1. Describe g as a transformation of f. Well, this is where it gets tricky. So if it's on the outside like A, this means it's going to deal with vertical. And since the number is bigger than 1, it's a vertical stretch. Okay, by 2. So how we do this is I have my g of x equals 2, and then whatever f of x is. So f of x is 2x to the fourth minus 6x squared plus 1. And then I have to distribute it. So I get g of x equals 4x to the fourth minus 12x squared plus 2. And this is my new equation with my description of saying it's a vertical stretch. Now, the difference between A and B is in A, the 2 is on the outside while the 3 is on the inside in B. So meaning anywhere I see an x, I'm replacing it with a 3x. Since it's on the inside, this is what deals with the horizontal. Okay, and this is actually going to be a horizontal compression by, it looks like it's 3, but it's really going to be a 1/3 because we make that and turn it into a fraction. Okay, so this is where it does get tricky. So now, everywhere I see an x, I'm plugging in 3x. So I have g of x equals 2 times 3x to the fourth minus 6 times 3x squared plus 1. Okay, from here I have to do order of operations. Order of operations tells me that I have to do my exponents first and then multiply. So I get 2 times 3 to the fourth x to the fourth minus 6 times 3 squared x squared plus 1. So 3 to the fourth power is 81, so I get 2 times 81 x to the fourth minus 6 times 3 squared, which is 9, times x squared plus 1. So 2 times 81 is 162 x to the fourth. Negative 6 times 9 is a negative 54 x squared plus 1. And this is my function that describes the horizontal compression by 1/3. So I got my equation and I got my description. Looking at the last example, I have let f of x equals 16x to the fourth minus 24x squared plus 4. Describe g as a transformation of f. If I notice on A, it's on the outside, the 1/4. So since it's on the outside, it's a vertical. Okay, and it's a compression because it's between 0 and 1. By 1/4. Okay, so what I end up doing here is I take g of x and I multiply everything by 1/4. So I have 16x to the fourth minus 24x squared plus 4. Since I'm multiplying by a fraction, remember fractions are the same thing as division problems, so I'm going to really just divide every term by 4. So I have 1/4 times 16 to the fourth, which just turns out to be 16 divided by 4, which is 4x to the fourth. 1/4 times a negative 24x squared is the same thing as negative 24 divided by 4, which is a negative 6x squared. And then 1/4 times 4, or 4 divided by 4, is a positive 1. So my equation got smaller. Looking at the last one, b, g of x equals f of x, or f of 1/2 x. So since it's on the inside, this has to do with horizontal. Okay, since it's between 0 and 1, this is a horizontal stretch by 1/2. Now, anywhere I see an x, I'm plugging in a 1/2 x. So I get g of x equals 16 times 1/2 x to the fourth minus 24 1/2 x squared plus 4. So again, I get 16 times 1/2 to the fourth. I get x to the fourth minus 24 times 1/2 squared x squared plus 4. So let's start simplifying. So 1/2 to the fourth. I take 1 to the fourth, which is 1. Okay, that's not too bad. So I get 16 times 1. 2 to the fourth is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I get 1 over 16 is 1/2 to the fourth, and then I get x to the fourth minus 24. 1 squared is 1. 2 squared is 4. X squared plus 4. So now I just multiply, or I can divide. So 16 times 1/16, or 16 divided by 16 is just 1. So I get x to the fourth. Negative 24 times 1/4, or negative 24 divided by 4, is a negative 6 x squared, and then plus 4. So this is my function that is a horizontal stretch by 1/2. So this is again the video for transformations of polynomial functions.